What are the tools that you have in your kit bag? What's your approach? How do you know what to use where, and what are the options that you're favoring? What are your favorite tools for tagging?
Well, so the platform that we've built is key for that. So the platform is intelligent enough to kind of drive the use cases, and from the use cases, the toolkit gets laid out in front of our customers. And the toolkit includes the sensors that are needed for that specific use case, and then they can be adjusted based on requirements for battery life, budget available, and then the processes that you use to adhere the stickers or the tags to the various raw materials or assets. The use case kind of defines the toolkit that you're going to use. Probably my favorite right now is the new mobile app that is fully integrated with our platform. It is actually the culmination of 3 years of work with a few Fortune 100 companies and how they operate and how they utilize IoT on a daily basis. So we've done everything from two scan process to associate sensors with an asset and two scans, whether it's a barcode and the QR code on our beacon or a sticker, and it's associated. So we've drastically removed the time requirements for attaching and associating devices. We've worked really hard to remove a lot of the roadblocks for disassociating and reusing some of these sensors. That's all built into our platform now and built into our new mobile app. But I'd say the real game changer for us in 2020, as we kind of get to the end of 2021 and 2022, is we are starting to use the term everything a lot now. And so um, I know this might sound like I'm promoting something, but I'm not. It's simply what we see, and the wiliot sticker takes us from tagging a few thousand things or 100,000, 200,000 things to tagging millions of things. So for a company that depends on data from millions of things is so much more valuable than data from thousands of things. That's a very important part of our new toolkit.
And that's a cost thing primarily. The lower cost allows you to just go from tagging expensive things to lower cost things. Is that how you're getting to the volumes?
That was why that's why we actually approached Wiliot to begin with, was the
Hmm.
cost, because it's a substantial cost difference in a battery powered active beacon down to a passive sticker. But because of the industries we're in, classified areas are an important part of what we do. We've invented some special gateways, or my team has invented some special gateways that will flag you if something with any type of a signal enters a classified area. The
Hmm.
ability for a passive sticker to disperse its power and turn itself off inside of a classified area is absolutely valuable to what we do. Now we can track all of the raw materials in the areas where it's allowed, and we use algorithms and AI to decide if it's made its way into a classified area, and it provides a tremendous amount of valuable data to our
Why
customers.
why would you need AI to do that?
Well, there's a difference in how the stickers interact with our algorithms and interact with our infrastructure. Our infrastructure was tuned to battery powered active beacons that can broadcast up to 1,000 feet and that can broadcast 3 times a second. So
Hmm.
the way a passive sticker, the range a passive sticker has, the way that you have to energize it, the range in which it broadcasts, it
Hmm.
required a substantial amount of changes to our algorithms. But we've already done the work, and it's highly valuable now. The other reason the AI is required is because you can have no signal inside a classified area. You need to be really sure it went in that area. It could have gone down a hallway with 10 or 11 doors. And did it go into an area that's not energized, or did it make its way into a classified area? We've built models that learn and have figured out how to tell you exactly where something is, regardless of the ability to have it energized at this moment in time.
That's really interesting because I think, I spent a lot of time trying to explain to people the difference between this wiliot IoT Pixel technology, these Bluetooth stickers, passive stickers, some people would say, and RFID. And I think you kind of put your finger on something that you're doing to accommodate that, which is the continuous nature of and the coverage. And I firmly believe that RFID has got a place and it's going to continue to grow and thrive. But it is kind of a point in time. It's a snapshot. Whereas I think what you're describing is a continuous view of, okay, this is radio technology. So I'm probably not going to see it 100% of the time everywhere. I'm going to pick it up and I'm going to have this continuous view and sightings. And it sounds like what you're talking about is the ability to amass those sightings and make sense of them in a way that maybe you couldn't do if you had someone running around with an RFID reading gun or some $10,000 tunnel that only occasionally got used. You're kind of doing the continuous view and then making sense of all of those signals. I don't want to put words into your mouth, but am I heading in the right direction there?
You are. It would be a whole new podcast for us to have the discussion around whether RFID will survive or not. At thinaer, we think RFID is done, especially with the introduction of the BLE, wiliot BLE sticker. The infrastructure required for RFID just doesn't have the ROI backing for it. It's costly infrastructure. It's limited in what it can do. BLE infrastructure can do so many more things. There are so many more BLE sensors coming to market every day that if that's the infrastructure you've rolled out, and there's the ability to get the low-cost BLE sticker, we just don't see a future for RFID. But back to your comment, yeah, we've used AI. We've created, I think, a nice hybrid model that says there are areas that you'll care about where these stickers are at all times. We've found a way to energize those areas. There are areas that you'll want to know as many times as possible in a 24-hour period if you can see it or not. So what we've done is we've created this approach where we may flood some areas with energy. Other areas we'll use a robot or a forklift to disperse energy occasionally, and then let our mesh gateways pick up the signals at those times and do locationing at those times. And we've created, I think, a model that's very, very valuable for the customers, that has absolutely allowed us to start tagging everything instead of some things.
And explain a bit more about this energy. I mean, obviously, I'm live and breathe with you every day, so it makes sense to me, but other people may not know what you're referring to. You're dispersing energy. What kind of energy is that?
Yeah, so there are two ways you can disperse energy for the stickers. Let me back up and talk about an active Bluetooth beacon. Has its own battery, has its own energy. It's constantly broadcasting up to 1,000 feet of its BLE 5. With the sticker, there's no battery on it. So you have to provide the energy from the air around the sticker. And what we really like is the new option to have either LoRa, long range energy, or the BLE energy. So BLE energy, the beauty of it is it's the 2.4 gigahertz spectrum, that everything that you can buy off the shelf at Best Buy and Amazon all run in that spectrum. So as long as you've got a Wi-Fi extender or something that can disperse 2.4 gigahertz energy and it gets into close range of these stickers, it will wake them up and allow them to broadcast. And so my team, we've got a tremendous team, Taylor, Paul, Bryce, We've got a tremendously intelligent group of guys who are uniquely qualified for what we're doing, and they have found this great hybrid model for how and where you disperse energy using basically off-the-shelf products, which is an amazing thing for customers. So, think about, do I want a $1,200 to $1,500 RFID reader, or do I want something I can buy for $49 from Amazon that provides the energy to wake up these stickers?
And when the idea of robots walking around, energizing and reading, or mobile is interesting. Can you flesh that out a little bit more? When would you use a stationary bridge or gateway, a reader, and when would you use something that's actually moving around?
That's a good question. So there are two ways we use robots. The first way, the most prominent way we do this is we will have our gateways spread out in a mesh setup across a warehouse or across a factory. So they work together, sweeping the air 3 times a second for signals. They're constantly doing that 7x24, 365. So anytime a signal arises, they'll see it, they'll work together to trilaterate it. They'll investigate the packet of information that comes from it, put it into our platform, and that's where all the magic happens. So what happens with a robot or a forklift is, in this situation, they're only running around dispersing energy. So we've got a Wi-Fi extender or some type of a capability to disperse 2.4 gigahertz or LoRa energy as it goes up and down the warehouse. So in the warehouse example, if you think about an aisle in a warehouse and 3 stories of shelving, everything on those shelves has stickers on them. They're all asleep most of the time. There's a little bit of energy from our gateways that the stickers are utilizing, but it's not enough to fully wake them up. As the robot makes its way down that aisle, though, it disperses the energy, wakes them up, the gateways locate them, pull information from the packets, and it continues to do that up and down the aisles. So with a robot, think about a customer. We've got a customer that can do cycle counting about once a year for everything, once a quarter for important things. They made the comment, using the robot, using the stickers, using our gateway infrastructure, is 365 times better than what they had before, because the robot can wake everything up every night, and our gateways are sitting there waiting for them to wake up to read the energy from them and trilaterate and tell you exactly where they are on a map. That's the first example. The second example is an area where you don't have our infrastructure. We'll put a gateway on the robot, and most of the time the robot has internal GPS coordinates that we can read from. And so as it makes its way up and down an aisle, it will not only use energy to wake up the stickers, but it will use its indoor GPS readings, if you will, to report back on locationing. That's not quite as accurate, but for a lot of customers, for a lot of use cases, knowing it's in this part of this room, in this warehouse, is far better than they ever had before.
Thanks for watching this clip from the Mr. Beacon podcast here on YouTube. You can listen to the rest of this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video, and be sure to subscribe for more weekly videos. For more information about Wiliot and IoT Pixels, head on over to wiliot.com.